Okay, so the next question I'm going to do, which is the third question I'm going to do, is a question that deals with the electron configuration of a copper 1 ion. It's a HL question from the atomic structure chapter that we have studied. Now, it's not a normal copper atom. We deal with the normal electron configuration of copper later on when we solve it. But then we have to realize, since the electron configuration of copper, we do realize from all of the answers that they all have, they all have the same electron configuration up until 3p6. So you could ignore all of that up until 3p6. Now the difference is that option A has 4s1 3d9. So it has 4s1 3d9. B has 4s2 3d8. So one more in the s orbital and one less in the d orbital. Option C has 4s1 3d10, which is two more from option B in the d orbital and one less in the s orbital from option B. D, however, only has 3d10. So they're all the same right here up until these ones. Now, if we look at the periodic table, we should divide the blocks, quote-unquote blocks, into groups or different blocks in the periodic table. Since this question also has chapter 3 in it, which is the periodic table, from chapter 3 what we can deduce is that this block over here, so the first two groups, are the s orbitals, and all of this section over here, the transition metals, are the d orbital or the d block, and all this over here are the p block. Now, since these two have a maximum of 2 electrons being filled in one s orbital, the maximum it could reach is, from this analogy, is 2. So 2 electrons in one orbital. P, on the other hand, has 1, 2, 3, 4, 5, 6 groups, which means 6 electrons. So the maximum should be P6. D, however, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups, 10 electrons. The maximum is 3d10. F, however, we could ignore it since it's very rare to come up with a problem with these two rows right here. They are the F block. So this is the F block. Now, when we look at copper, right over here, it is in the D block. So that's one part of the knowledge being given. It's in the D block. It's not in the S block, as it's not in the P block, and obviously it's not in the F block. Now, is it a 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? We should count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 3D9. Now, generally, in the chemical point of view, the electron configuration of copper is, to summarize it or to condense it, we can say it's argon. So it's the exact same configuration up until argon, and 3d10 for S1. That's the normal configuration of copper itself in the neutral state. Now, because copper has this configuration right here, the full 3d10 orbital, as we said, that because the maximum amount of electrons filled in the d orbital should be 10, they have a lower energy than the s orbital or the p orbital, and therefore it prefers filling up the 3D subshell, which is this section right here, with 10 electrons, and then leaving the 4s subshell, which is here, 4s subshell with 1 electron only, which can be analyzed over here. Now, because of this, the copper ion with a plus charge, which means taking away an electron, therefore we should remove the electron from the s orbital, because removing one electron from the 4s orbital or the 4s1 subshell is easy to remove than the d orbital, because the 4s orbital is a higher, like we could analyze it like this. This is the 4, 3, 2, 1. The 4 is a higher energy level than 3, and 3 is higher than 2, 2 is higher than 1. So it's easier to remove the individual electron in the 4 orbital, in the 4th energy level, than the full d subshell with 10 electrons. Therefore, removing 1 electron here gives us a configuration of argon 3d10. Now, what is the argon's configuration? It's 1s2, 2s2, 3p6, or sorry, 3s 2p6, 3s2, 3p6, 3d. Now, what is the argon's configuration, since we have removed the 4s electron, or the electron from the 4s orbital? The argon configuration is 1s2, 2s2, 2p6, 3s2, 3p6. But however, since it's copper plus ion, it's also 3d10. Now this is the answer. The answer is D. Now let's look at why A, B, C are wrong. Now C is a wrong answer because this is argon 4s1 3d10, same as 3d10 4s1, but because it's wrong, it's the actual electron configuration of a normal neutralized or a normal atom, copper atom in its neutral state. And the question is asking a plus ion, positively charged ion of copper 1 ion, by removing 1 electron, which means removing this and giving an answer of 3d10. So that's why C is incorrect. Now, why B is incorrect is because it's 4s2 3d8, and it's actually the electron configuration of nickel. Now, this also goes back to the point of copper being an exception regarding the half subshell spinning, which I actually looked up before this question because it's kind of complex. That chromium and copper are exceptions to the electron configurations because of the spinning and electron spinning. But anyways, in general, this is the nickel's atom configuration of 4s2 3d8. The removal of the electron in the s orbital before the d orbital does not apply to nickel, as we could see over here. The 4s orbital is still filled, but however, we removed 2 electrons from the maximum of 10 to get nickel. So the maximum was over here. This is 10. We went 1 and 2, which gave us a 3d8. Now for A, this right here doesn't generally make sense, the 4s1 3d9 part of it, because if it was just argon 3d9, it would have made sense. It would have been the electron configuration of copper 2+, because we originally had for us an s orbital that's full, but because we removed 2 electrons, we should have removed this, and by removing an electron we should see that the d orbital would have 9, because that's the electron configuration of copper. Well, not the electron configuration of copper itself, but it's the electron configuration of copper in regards to the exception plus the removal of 2 electrons. But because we have a 4s1 and a 3d9, it wouldn't have made sense, because it's either the s orbital not full or a d orbital not full. When it's 4s1 3d9, it's saying that we removed an electron from the s orbital and we removed a d electron from the d orbital. If we would have removed this and this would have been a 10, it would have been the correct answer.